Hello and welcome to our webinar on NB-IoT and LTE-M field measurements. My name's Ben Stone and I'm with RCR Wireless News. In this webinar, we'll be talking about how to perform RF measurements and how Keysight's Nemo data collection and analytics tools brings value to the process. Nemo tools have been used by network vendors as well as operators successfully in field measurements across the globe. Keysight actually announced just yesterday successful measurements with Nordic operator Telia. Today's webinar will be presented by Alex Chua of Keysight Network Testing. Over to you, Alex.
Thanks for the introduction, Ben. A warm welcome to all the attendees to this webinar hosted by Keysight Technologies. I'm Alex from the network testing team, and today I'll be talking about IoT-related technologies, specifically Narrowband IoT and LTE category M1, using Nemo Network Outdoor Test Tool. Nemo Outdoor is an RF field measurement that is suitable for collecting RF measurements of both cellular IoT as well as regular LTE measurements. The agenda for today includes an overview of Keysight Network Testing Group, a section on the Internet of Things and 3GPP IoT Release 13 related technologies, Nemo Narrowband IoT and LTE category M1 measurement solutions using Nemo Outdoor, which allows us to measure coverage, control payload transfer, the level of support in our collection tools, the metrics that are collected, as well as the support in our data analytics tool. We'll then dive into a short demonstration, followed by a quick summary. As you may be familiar, we are from the Nemo network testing tool that has been acquired by Keysight two years ago. Our products are used by more than 400 mobile operators worldwide, as well as network equipment manufacturers and service contractors. Our tools are better known as drive test tools. It's used for network optimization as well as network rollout. Our portfolio includes two distinct product lines, specifically Nemo data measurement tools as well as data analytics tool. And what we've introduced recently is Nemo Cloud, which allows us to bind the collection tools as well as the analytics tool through a cloud portal. On the measurement tools, we do have two product lines as well. One being the PC-based solution with Nemo Outdoor, which is extendable into a chassis-based solution with Index 2, as well as an Android portable-based solution with Nemo Handy, extendable into a backpack tablet-based solution known as Nemo Walker Air. We do also offer autonomous probes that can be remotely controlled through Nemo Cloud. On the post-processing side, we have enterprise-based solution with Nemo Synergy, including DAS small cell modules, network measurement, drive tests, as well as geospatial intelligence. PC-based desktop post-processing tools are also available with Nemo Analytics, including Nemo Windcatcher, as well as Nemo Analyze. Taking a look at the Internet of Things, it's a very broad-based technology, and I wanted to take a very high-level view just to give a snapshot of what we talk about when we look at wireless IoT. There's a whole group of multiple complementary and competing technologies in the mix, including the technologies like Zigbee, Wi-Fi, Bluetooth, etc., as well as LoRa, Sigfox, 3GPP-based technologies, as well as GSM. All these technologies have a play in the Internet of Things and allows us to get to the level of a connected world. I would say that the main differences between the technologies on the left versus the technologies on the right is the access to the Internet. And technologies on the left, like Wi-Fi and Bluetooth, typically require a gateway solution in order to gain access to the Internet. Whereas the technologies on the right, such as LoRa, Sigfox, 3GPP-based technologies, typically have a network infrastructure that is available that allows access to the Internet. More commonly known these days is the terminology of LPWA, low power wide area technologies, and LoRa, Sigfox, and 3GPP-based technologies fall under that bucket. Specifically with Nemo tools, we wanted to take a look at the 3GPP-based technologies with Narrowband IoT as well as LTE category M. Starting with 3GPP release 13, 3GPP has introduced the LTE category M and NB-IoT. I wanted to share this slide over here just to indicate a little bit of difference between the two technologies. Both technologies are relevant in the machine type communication technologies, but there are slight differences, and both are complementary, and they could be deployed on the same network. LTE category M1 supports full duplex, whereas NB-IoT only supports half duplex. This decision would drive things like whether voice is needed. The full duplex LTE category M1 will be able to support IMS voice calls, whereas NB-IoT, it will not be possible. The data rates of NB-IoT is also significantly lower than category M1. However, NB-IoT does have some benefits in terms of coverage. It has about 8 dB if it's deployed in a standalone manner, 8 dB gain compared to LTE category M1. In addition, category M1 supports full mobility, whereas NB-IoT operates in more of a nomadic fashion. Given the technology, it drives a decision on what selection a user, an end product would take in terms of using NB-IoT or LTE category M1. If we take a look at LTE category M1, as well as NB-IoT, I would classify these as very sleepy technologies. They tend to go to sleep for a long period of time, waking up and efficiently transferring messages into the network and going back to sleep. This allows these technologies to conserve battery and enable the 10 years of battery life use case. What was introduced in the specification is power safe modes as well as EDRX modes to allow for longer sleep cycles in these technologies compared to regular LTE. NB-IoT operates in the same fashion. It has additional coverage enhancements compared to NB-IoT. And by supporting half duplex operations, it enables manufacturers of chipsets to be able to reduce costs, enabling the RF front end to be reused for both the transmit and receive. One other interesting implementation with both NB-IoT and category M1 is the use of control plane to transfer data without having to set up a user plane session. And this enables efficient message transfer from device to the network. Given that NB-IoT and category 1 are coming from the 3GPP space, there are also provisions made to allow for easy deployment based on LTE PRBs. If we look at LTE category M1, it actually consists of 6 LTE PRBs, whereas NB-IoT consists of 1 LTE PRB. With that, it dictates the deployment style of category M1 versus NB-IoT in a network, with category M1 occupying 6 contiguous blocks in an LTE spectrum, and NB-IoT allowing it to be deployed both in band, guard band, as well as onto existing GSM spectrum as a standalone. So based on this, we could see the deployment decisions that operators are largely driven based on what existing technologies there are on the network. For operators who still have GSM deployed, NB-IoT is an easy transition, whereas for operators who do not have GSM spectrum, category M would be a logical transition. At the end of the day, we will see that both LTE category M as well as NB-IoT would coexist on the same network. If you take a look at the worldwide deployments, you can see that all across the globe, operators are starting to roll out NB-IoT as well as category M1. And this is information data from June of 2017. Moving into the Nemo solutions and how we are measuring NB-IoT and category M signals through the Nemo outdoor tool. The measurement use cases are clear. IoT value proposition has to be verified in terms of the extended coverage, the coverage enhancement functionality that was added into these technologies, the battery life, as well as network capacity. For the Nemo team, we see various use cases of our tool, including early lab field testing, device and network acceptance, benchmarking, as well as SLA verification and monitoring. Here is a sample report that is generated through Nemo post-processing tool, where it provides a list of metrics that has been collected on the network based on NB-IoT. In terms of coverage analysis, we do see that there are three areas that we can analyze in terms of technology performance, including service coverage, REDGE coverage, as well as signal coverage. So NB-IoT and Category M1 both provide extended coverage over LTE, and through our drive test tools, we're able to simulate measurements and traffic on the network. Here's an example where we're running pings and checking the round trip time versus the RSRP. Nemo Outdoor allows the user to run operations such as ping, FTP, SMS, and this is typically what we are seeing in terms of the data transfer that's happening on the IoT network, where it's very basic type of transfers such as short messages, as well as pings in terms of trying to get a sense of the latency as the signal strength goes low. The key metrics that we capture out of service coverage includes application performance, ping round trip time, ping success rate, application throughput, layer 3 payload bytes. On the RF side, we do collect radio performance, MAC throughput modulation, MCS, PRBs, and the various RF parameters. Taking a look at signal coverage as part of the coverage analysis, it is important, obviously, to have sufficient signal coverage in order to get good service. And that's where Nemo Outdoor is able to capture all the required RF parameters, including RSRP, RSRQ, as well as SNR. Given that NB-IoT does not support handovers, we do also support the use of scanners, protocol scanners, such that in the event where NB-IoT is in an active session and it is not scanning the neighbor cells, those measurements can be taken through an RF scanner. REDGE. REDGE coverage is another area that we feel is important with these IoT technologies, given that it's operating in very low signal strength area, and each time when the device wakes up, it needs to connect to the network. We want to see how many preambles there are in order for the device to connect to the network. And Nemo Outdoor has a predefined template for measuring REDGE. Key metrics here include number of preambles, REDGE results, as well as access delay. And this, we believe, is important in testing low coverage or deep in-building setups. With IoT, there is also the rollout of non-IP delivery mechanism. And Cellular IoT allows the carrying of payload over the control plane signaling, such that there is not a requirement to set up a user plane. So this allows low overhead of the radio bearer and resources. As you can see, Nemo Outdoor captures the layer 3 message and is able to pass the payload, the layer 3 payload, through our post-processing engine, Nemo Analyze. In IoT, there are 3 ways of transferring information. There is a control plane with SMS service, control plane with no user plane, and control plane with user plane. Obviously, the most efficient way is to not have to set up a user plane. And this allows the IoT technologies to efficiently transfer data across the network. Looking at our measurement tools, Nemo Outdoor is a drive test measurement tool, and we've added support for high silicon Bodica chipset as well as Qualcomm MDM9206 chipset. The high silicon Bodica chipset supports LTE narrowband narrowband IoT technologies. And the devices that we're using to connect up to Nemo Outdoor includes the Quectel DC95 development kit, the later USB device, as well as the u-blox Sarah development kit. On the Qualcomm NBM9206, it supports both NB-IoT, category M1, and eGPRS. The devices that we're using include Qualcomm reference terminals, Quectel BG96 development kit, u-blox Sarah R404 development kit. We're also introducing support for scanners, starting with the PCTEL IB Flex and MX Flex scanner. Starting early next year, we'll also include layer 3 decoding through the PCTEL IB Flex, as well as adding support for the Rovian source PSME, PSMW scanner. In addition, we're continually looking for new test devices that can be added to Nemo Outdoor for field testing. We are also enhancing our IoT implementation by allowing users to force the PSM and eDRX mode while using Qualcomm-based chipsets, allowing the testing of different power safe modes. The parameters that we're collecting on the NBM9206 includes the following. It basically covers most of the essential RF as well as signaling messages. And for LTE category M1, the KPIs we are collecting are the same as regular LTE chipsets on the Qualcomm frame. So things like the operation mode, in-band, the same PCI, in-band different PCI, dot band, standalone, these we are capturing, as well as the MNC, MMC, all the RF parameters such as RSRP, as well as layer 3 signaling. On the high silicon Bolliker chipset, very similar KPIs that we're collecting. So we're noting down the packet technology, the operation mode, as well as the MNC, MCC, and the layer 3 signaling. So these are the two chipsets that we're currently supporting with the Nemo Outdoor PC-based solution. On the data analytics side, available today on Nemo Analyze 8.0 as well as Nemo Windcatcher 3.6.3, we have added support for narrowband IoT and category M1. So there are standard templates, report templates that can be generated through these post-processing tools. We started the rollout through our PC-based solution, and we're going to add it on to Nemo Synergy, which is our enterprise-based post-processing tool early next year. In addition to that, with the addition of scanners on Nemo Outdoor, starting 1Q next year, we're going to add support for scanner analysis as well with the post-processing tools. So now I'd like to step into a quick demo with Nemo Outdoor, with live measurements that were taken from the Dallas area. So this is the Nemo Outdoor PC-based application. What I have here today is a playback of measurements that were taken recently in the DFW area. And this is based on the LTE category M1 chipset. Setup here is fairly standard. What we did was we did a drive around the area. As you can see, this was the drive route that was taken. And the strip sequence is very standard. It's basically a ping, an FTP, an SMS. And as you can see, here we're capturing all the major RF parameters, including the packet technology, the MNC, MCC, as well as all the RF parameters. In addition, we're also capturing all the timing advance, TX power, etc. MAC layer information, data throughputs, as well as signaling and reg. And here we could see that the reg report that is available through Nemo Outdoor. In addition to that, we're also capturing the layer 3 information in real time as well as decoding it through the tool. So Nemo Outdoor is a fairly flexible data collection tool that can be used to collect IoT measurements as well as regular IoT, regular LTE. One of the interesting things that we've seen with IoT, where we do not see with LTE, is that the measurements do go deep into the low coverage or low signal strength area, and where in LTE, we're seeing signal strengths of NAC 100, NAC 110. With LTE category 1, we're actually seeing results down into NAC 140, 150 dBm. So this is an example of a measurement that was taken with LTE category M1 using Nemo Outdoor tool. Based on the results and measurements that were taken in the field, we have another set of measurements based on narrowband IoT, and this was taken somewhere in Europe, where we're also comparing the RSRP versus the ping round trip time. And as you can see, as the signal strength gets lower, the round trip time is significantly higher. And when as signal strength gets better, the round trip time decreases. So this is a sample taken from Europe. So in summary, both narrowband IoT and LTE category M1 are starting to be deployed worldwide. There is a need for the verification of the technology, and that includes early lab and field testing. In terms of troubleshooting and understanding the interactions between the network as well as the chipset. There's a need to verify the service coverage, device and network benchmarking, rollout and acceptance, as well as SLA monitoring. Now I'd like to step into the Q&A section. Please feel free to raise any questions that may be of interest to you.
Well, that's great. I'll let us start everyone off perhaps with a quick question then for Alex. Can we get test devices for NB-IoT and LTE-M via Keysight as part of the measurement solution?
Yes. So we do support the collection of LTE category M1 and NB-IoT metrics through our PC-based solution, Nemo Outdoor. Currently, we're using a couple of different terminals kits, including the Quectel boards, Qualcomm reference device, as well as U-Blocks kits. And these are typically connected over USB to the PC that's running the Nemo application. And once it's connected to Nemo Outdoor, we're able to control the device, set it to run various operations, including ping, FTP, SMS, and in cases, placing voice calls as well through these IoT kits. It is a fairly flexible solution, and in cases where a user wishes to compare IoT-related technologies with LTE handsets, it is also possible through Nemo Outdoor. Our solution allows the connection of up to 9 devices, so you could have one NB-IoT, one category M1, a CAT-16 LTE device, all connected to Nemo Outdoor, running various operations and comparing the KPIs that are collected.
Great. And Alex, do you support in-building measurements?
We do support in-building measurements, and we do even support the import of floor plans through the Nemo Outdoor kit. At this current stage, I would say it's more of a practicality issue in terms of the setup, since the kits are more like a reference board, so it may not be conducive to be walking around with a board, but it's certainly possible. We continue to look at end equipment that would be easily connected to Nemo Outdoor in order to ease the use of an in-building walk. But certainly the kit today as it exists, it's possible to run in-building tests. Whether it's a walk or a spot check within certain locations within a building.
Great. And do you support SLA and QoS monitoring for cellular IoT?
Yes. So we do see that SLA is one growing aspect of IoT, just to ensure that the lease spectrum, a lease service from the operator is operating as intended. One option with the Nemo tools is to use it in an autonomous fashion, such that it would be an enclosure box that is installed at specific locations within the building, controlled by Nemo Cloud, allowing the user to remotely monitor the performance of the IoT network. And this, does not just apply to IoT; it can also apply to regular LTE.
Great. What's the device for IoT testing? Is it a handset or is it an IoT chipset device with Nemo?
With Nemo currently today, there are various, I wouldn't say various, but a couple of devices that we're using, including development boards, reference boards coming from Quectel, as well as U-Blocks kits, which are more well enclosed in that sense.
Great. Do you see a difference in signaling measurements sent by different category of NB-IoT or LTE-M1 devices?
Do we see different signaling? Can you repeat that?
Yeah. Do you see a difference in signaling measurements sent by different categories of NB-IoT or LTE-M1 devices?
We do see some differences as the networks are being rolled out across the globe. I would say that one of the characteristics that we are seeing in NB-IoT is that it appears that the non-IP data delivery mechanism appears to be implemented in the NB-IoT network, and we can see that through the signaling. Whereas with category M1, it looks like the non-IP delivery mechanism has not been implemented yet on some of the networks. So we do see the differences through the signaling between NB-IoT and category M1.
Awesome. How do you test load conditions under CAT-M1?
Load conditions, I would say we are running both FTP sessions to check the peak rate on the NB-IoT technologies, but at the same time acknowledging that the peak rates are not essentially the most critical parameter for NB-IoT network, given that the use case for NB-IoT is more intended for huge power savings together with coverage enhancements. I would say where devices that uses NB-IoT would be sending small amount of packets on a daily basis back to the IoT service. The effective throughput may not be as critical as latency or round trip time to the network. But we are able to load the IoT device if a user decides that that's the test mechanism that is needed for test mechanism that's needed for that use case.
Great.
And throughputs that we're seeing are somewhere on NB-IoT throughputs that we're seeing are probably effective throughputs are in the 100+ kilobits per second, with LTE category M1 we do see somewhere in the 350, 400 kilobits per second range.
Great. A question asked by the audience member: why are you finding such deep, low sensitivity on IoT, narrow channel, less traffic interference, and is it the same case as in band IoT?
So we have not run that comparison yet between a standalone deployment of narrowband IoT versus an in-band deployment of IoT. To compare the coverage differences, there is somewhere along the lines of, I think, 15 to 20 dB difference, if depending on how the NB-IoT is being deployed. But per the design of the specification, it is intended to go down to MEC 164, depending on the CE, the coverage enhancement mode that the device supports.
Great. Another question from the audience. Not quite sure exactly context, but what about the indoor-outdoor range problem?
Indoor-outdoor range problem. Wonder if maybe the attendee can clarify the question. See, if I understand correctly, he's asking if going from an outdoor environment into an in-building environment, what is the loss in coverage?
Mm-hmm.
So I guess the scenario can occur in two fashions. There would be two, I would say maybe two ways to look at it. It would be outdoor to indoor with an in-building network such as DAS or small cells, outdoor to indoor with no DAS or small cells in the in-building environment. And from outdoor to an in-building DAS environment, we would probably want to see the handover on LTE category M1 from the outdoor to the in-building environment. For facility or site, in-building site that does not have any in-building networks, then we want to check how low the coverage goes and what the signal strength is seen within the in-building as the user walks from the outdoor into the in-building environment. So I guess there are two cases. One case where there is an in-building DAS or small cell network, and one case where the in-building does not have a DAS or small cell network.
Great. Thanks, Alex. What's your projected cost range per a COM point for connectivity, assuming you have 500 total points with a variety of NB-IoT, LTE over a 1,700 acre site? 17,000 acres.
17.
Yeah, 17.
So we're coming from we're coming from the test and measurement solution perspective. So I assume the question is related to what would be the number of test setups that would be needed to measure the performance of a network that has 500 connectivity points across 1,700 acres. For 500, what we've seen typically with customers, I would say that if it's for a drive test type of setup with 500 access points, I mean, it would be probably in the order of 5 to 10 Nemo outdoor kits for that size of a rollout.
Great. Do you see any degradation in IoT network of LTE network and congestion?
Not that we have seen degradation in the IoT network, since it is deployed with dedicated spectrum. In the case of LTE category M, it's 6 contiguous PRB blocks that is occupied in the LTE spectrum. With NB-IoT, in the event that it is deployed in the guard band of the LTE, there's always the potential for interference. And in the case of a heavily loaded LTE, that can be interference that might impair the performance of that guardband NB-IoT implementation.
Great. Can Nemo load the network under the test with hundreds of NB-IoT UEs and provide the drive test measurement?
So Nemo Outdoor supports up to 9 UEs per setup. So in order to connect 100 UEs, you probably need about 12 Nemo Outdoor kits. So it's certainly possible to do 100 UEs at the same time, but it would require 12 outdoor kits.
Thank you. How does 5G IoT differ from LTE NB-IoT?
So 5G IoT would be kind of an extension of, I would say, a evolution, if you will, of the current NB-IoT as well as category M1. So 5G takes a look at multiple different kind of use cases, including things like enhanced mobile broadband, massive IoT, as well as ultra low latency communication. So on the 5G side, there is a network slice that is kind of intended to be dedicated for massive IoT, whereas the current IoT technology, NB-IoT as well as category M1, is more taking a look at rolling out on the existing LTE network. So it will evolve into the 5G IoT when 5G becomes available. So there are provisions in the 5G technology to take into account the massive rollout of IoT technologies.
Thanks. Do we have layer 3 message details for IoT calls debugging?
We do have layer 3 messages. So Nemo Outdoor captures network layer 3 messages in real time, as well as decoding it through our tool. So a user will be able to see the interactions between the chipset as well as the network, things like the UE capability info, RRC messages. In addition to that, Nemo Outdoor also decodes SID messages. So in the case where there is an IMS overlay onto the IoT network, we are also recording the SID messages.
Great. And with tag/mark, could you bookmark some event with some info? What would help with later analysis? So, not sure what they're asking.
So Nemo Outdoor is a flexible measurement tool that includes a powerful script engine, map engine, and in addition to that, what we have enabled through the tool is textual notes. So a user will be able to add notes at certain points of the measurement, just for indicating specific events that happen at that point in time. So we do have that capability to add notes in our measurement tools.
Great. It looks like we do have some extra time for any more questions, or Alex, maybe if you wanted to show anything extra on a demo.
Sure.
One question that just came up, how do you test NB-IoT coverage, having in mind the limitation of NB-IoT devices concerning cell reselection?
So that's a good question, because NB-IoT operates in a nomadic fashion. It doesn't support cell reselection when it's an active session. So from our perspective, we do see the need to be able to scan for the other cells in IoT, in narrowband IoT testing, and we're we've added the support for the PCTEL scanner for narrowband IoT measurements with the ID Flex and the MX Flex. And in NB-IoT measurements, we do see that it makes sense to include both a UE as well as a scanner in those measurements.
Great. So one really good question here. Are there any testing scenarios for mission critical IoT testing that you could share?
So I would say that that's currently under in the investigation from our side. The use cases that we're seeing for the current rollout of IoT tends not to be on the mission critical side of things. The mission critical base IoT seems to fall more on the 5G with the ultra low latency implementation. And what we're seeing with the use cases today, like smart meters, smart parking structures, these tend to be less mission critical at this point in time. But we do acknowledge that the industry is moving as a whole to take a look at mission critical applications of cellular technologies, whether it's IoT or LTE.
Definitely. Well, thank you so much, Alex. Is there any more questions from the audience as we sort of wrap up the webinar today? Well, from Naveed here, can you elaborate on drive testing if there's no automatic handovers? Do you have to manually select cells from one to another in drive testing?
So with no automatic handovers, that kind of applies to the NB-IoT technology rather than category M1. And we see that with NB-IoT that potentially the test methodology may be more on the spot checking at various locations of a route rather than continual drive tests. Or you would go to one specific location, run the test, stop the test, move to the next location, run the test, stop the test. I think that's kind of how we see it on the NB-IoT site, where there are no cell reselections through the technology.
All right, great. Well, thank you so much, everyone, for your time. Thank you, Alex, for providing us that demo as well as your presentation. I would like to let everyone know that we will be sending out an email to all of you who registered to give you the webinar recording as well as the slides. If you have any further questions at all, do please reach out to nemosales@keysight.com. And thanks again, Alex.
Oh, thanks a lot.